Section 3, Chapter 10, and in this, believe it or not, section, yes, we've learned a ton of definitions. We've talked about arcs, we've talked about central angles, we've talked about chords already, we've talked about minor arc, major arc, semicircle, all that stuff. But in this video lesson, ladies and gentlemen, I'm going to show you 6, that's right, count them, 1, 2, 3, 4, 5, and 6, theorems that involve, as you see, relationships existing between chords, arcs, and central angles. So let's dive into this and show you how it works. Okay, first one I'm going to show you is, I'm actually going to show you all 3, well actually all 6, and then I'm going to come back on a PowerPoint and just put the wording up here so you can write them in your notes and have them for class and from there on out. But here's what I'm going to show you. What happens if we kind of just focus on central angles, so this angle right here and this angle there, the ones that are in the central angles, remember those from class, and if we make those two angles congruent, now right now they're not, you can see that obviously. Actually, I'll do this. Let me show you the angle measures. So if the angle measures up there are not even close to the same, one's 43.2 and one's 114. But if I make the two central angles congruent, I wonder what would happen to the lengths of the chords. Well, you probably have a pretty good instinct that's going on, but let's see what happens. Let's make this angle up here, well, this angle here, the central angle. I'll make this one really, really big. So let's make it exactly the same. Hopefully I can do it. We'll make it 114.3. So I'm going to show you this though. They're not quite the same. Let me show you the chord lengths. You can look, they look pretty close to the same. They look congruent. But here you go. Whoa, sorry. Move this over. So check this out. That's 8.16. That's 8.17. Not quite congruent. Nice try. But what if I take these two angles now and I make them exactly the same? Ooh, ba-bam, there you go. So the central angles are exactly the same. So this angle is now congruent to that angle. And you can see that the chord lengths are congruent as well. Now, let's take a step back for a second. What if we actually did this in a two-column proof, and I said, hey, given the circle, and you're given just the central angles were congruent, and I asked you to prove that AE was congruent to DC. Well, could you do it? Watch this. First of all, you'd be given those. They're not vertical angles. Be careful. They're given to you to be congruent. And then you could say this. AQ congruent to QE, congruent to DQ. Ooh, DQ. Dairy Queen. Is congruent to QC. All 4 of those are congruent. Why? You got it. All radii of a circle are congruent. So therefore, you can see this triangle up here is congruent to that triangle right there. So the triangles will be congruent through side, angle, side, which means then, ladies and gentlemen, through CP, CTC, ba-bing, you got those two chords congruent. So it makes complete sense. I mean, we certainly know that. It's nothing new in that regard of proving triangles to get other things congruent. But now we're talking a relationship between whenever we make congruent central angles, it would imply that the actual chords are congruent. So write this in your notes. Congruent central angles implies congruent chords. And yes, by the way, even though there is words I'm going to put them up here for you, that right there is what you can use in a two-column proof. Oh yeah, you gotcha. You got it. You're welcome. But let's go back and do this now. What happens if we kind of say, well, forget the angle measures. Let's make the actual chords the same. Well, you get, I'm sure you could guess. Let me make this 5.40. I'll make this one down here 5.40 if I can. I don't know. We'll see. So there you go, 5.40, that's a weird picture. But now I made the chords congruent. I wonder if that makes the central angles congruent. Well, I mean, you could prove it quick again, and I'm not going to do this with the other 4 theorems, but follow along. This sets the stage for the other 4. If I know that this chord's given to you to be congruent, and I'm trying to prove that the central angles are congruent, well, let's prove it. So given circle Q, given chords congruent, you could say in statement number 2, hey, all radii of a circle are congruent, makes all of these congruent. Step 3 would be the triangles are congruent through side, side, side. Step 4 would be that this angle is congruent to this angle, woohoo, because of CP-CTC. So a simple two-column proof can do it. But that's the scoop. That is one of the other theorems that's in the section. And you can see, there you go, bam, it worked perfect. So the central angles are congruent. So write this in your notes. Congruent chords imply congruent central angles. Now if I back this out, check this out. This is actually what's happening. Actually, I'll move it up. So you can actually see that these kind of go hand in hand. One goes one way, one goes the other way. You could do this. You can write it as an if and only if statement where it's saying, hey, if we have congruent central angles, that implies congruent chords, and vice versa. Congruent chords implies congruent central angles. Awesome. So there is the first two theorems. So let's go to the next two theorems, which actually, if you notice now the picture, I've gotten rid of the central angles. So now we're looking at chords. So what happens if we maybe make the chords congruent? I wonder what that would imply about the actual arcs. So this arc right here, DC, and this arc right here, AE. I wonder what would happen if we made the chords congruent. Well, you probably have a guess, but let's take a look. Let's make the chords exactly the same. So I'm looking at the lengths up here. I want to make them both 7.32. If I can do that, I should be able to, but we'll see. There's 731, there's 732. Cool. So if that's the case, these chords are congruent. Let's take a look over here and see what the angle measures. Not the angle, sorry. The arc measures. Bam. Perfect. So the arc measures are 115 degrees. So what I'm showing you is, if you know chords are congruent, that implies the measure of their corresponding arcs are going to be congruent as well. So into your notes, let's write this. Congruent chords imply congruent arcs. Awesome. Now let's go back. I'm not even going to do anything else other than this picture. Watch this. What happens if we know that the arcs are congruent? So if these two arcs are congruent, you got it. It's just the converse. That would imply that these chords are congruent. It works every single time. You know what? Let's see what happens. Let's make this guy really, really small. So let's make the arc 39. That means we've got to come up here and make this arc 39. Hold on. I gotta make it right. Remember what I told you before, what happens with this. It is very, very precise in what it's doing. So we gotta make sure that there we go. So we got the arcs to be 39 exactly. And the chord lengths are exactly 2.71. So there you see an example. So into your notes, put this. Congruent arcs imply congruent chords. So like I said, they go hand in hand. So if I move this up here, just like I did before, you're seeing the same exact thing. So congruent chords imply congruent arcs, but it also goes backwards, or the other way. It's not really backwards. It can go that way too. Congruent arcs imply congruent chords. So there are the next two theorems. So we've dealt with central angles implying something about chords, and now we've gone from chords and connecting it to arcs. So if you look at my fingers, central angles to chords, chords to arcs. I wonder if it's possible to take arcs and central angles and match them up and see if there's a correspondence there or a relationship that exists. Well, let's do it, shall we? So let's go to the last two theorems and let's see if this exists. What I'm showing you already, I've done this work because just to save time, but you see the arcs. They are, sorry, not the arcs, the central angles. I've got central angle AQE and central angle DQC exactly the same. They're already congruent. I wonder if that's going to imply the arc over here, its corresponding arc, and this corresponding arc. I wonder if they're going to be congruent. Well, I'll show you when I click on this thing right here. Notice, ba-bam. They are exactly the same. 83.5, 83.5, so that arc is congruent to that arc. So you got it. Move this over. Write this in your notes. Central angles do in fact imply that the congruent arcs are there. Awesome. Let's back it up. Oh yes, by the way, this is true too. You see this, great. So the arcs then would imply this central angle is congruent to this central angle. So let's write that in your notes. The last of the 6 little shortcuts. So congruent arcs imply congruent central angles. Awesome. Oh, a little side note. This is extra free of charge for you guys. I don't know if you noticed this or not. All these things are 83.5. That is not a coinky-dink. It happens every single time. And if you want to write this down as a little side note somewhere, we're going to use it later, do so. This happens every time. The measure of the central angle, guys, is always equal to and congruent to the measure of the actual arc. Always. Notice this. AQE was 83.5. Its arc was 83.5. Nuh-uh. Yes, watch. I'm going to move it so you can see what's up. Let me move this over here. I'll make it whatever. So notice the central angle is 31.4. Notice the arc, 31.4. Let me do the bottom one. Let me make the angle, I know, really big. So I'll make the angle 134.5. So this angle DQC, 134.5. Check out the arc, 134.5. That's actually not even in this section, but there you go. You learn that one. Hey, it's like a peace symbol. Yeah, peace. Okay, so let me show you this so you can write it in your notes. So those are your theorems, if you will, but let me give you a summary. Here's your summary. If you have congruent central angles, that implies for you got congruent chords. If you got congruent central, well, I said congruent chords, weird. Congruent central angles, bam, that implies you got congruent arcs. If you got congruent arcs, that implies you got congruent chords. This goes hand in hand. If you got congruent chords, that comes back here and says, wait, then you got congruent central angles. If you got congruent chords, great. That means you got congruent arcs. If you got congruent arcs, great. That means you got central angles. And they all just go hand in hand. So learn those. They are hugely beneficial for you. And again, when you use them in two-column proofs, I am 100% cool, guys. If you want to do this, if you want to write either one of these two, that's fine. If you want to write either one of these two, that's fine. If you want to write any one of these two, that is perfectly fine. Now, I'm going to not do this. I actually have it over here, but I'm not. I want you to look in your book and write down the wording of theorems 79 through theorems 84. But you know what's really cool about this? If you guys really look at what's happening, if you know 3 of the actual theorems, you know the other 3 because they're just converses of each other. Like I said, they go hand in hand. Learn them. Memorize them. Master. See you guys in class. You guys are awesome. Peace.